Hi friends, I'm your host Christine Holly Ngo, and welcome to another episode of Making Things Fun, Cool, and Sexy, where we explore the awesome world of manufacturing by interviewing and promoting American manufacturers to help localize the supply chain and to create more jobs for our country. I drop episodes every Thursday, and I switch off from interviewing a manufacturer, then taking the next week to dive into the subject further so that I can learn more about the industry and share it with all of you too. In this week's episode, we delve into why brazing and heat treating are essential manufacturing processes. As you saw last week, I interviewed Glenn Ottinger, CEO and President of Thermofusion, where they specialize in both processes. Today, we'll go through these three topics. Number one, what is heat treating? Number two, what is brazing? And number three, the importance of heat treating and brazing. Heat treating, also known as heat treatment, is a manufacturing process used to alter the physical and mechanical properties of materials, typically metals or alloys. But Glenn has actually heat treated plastic for me, so it also works with plastic. It involves heating the material to specific temperatures and holding it at those temperatures for a predetermined amount of time, followed by controlled cooling. Heat treating can impart desirable characteristics to the material such as increased hardness, strength, toughness, ductility, or improved machinability. There are several common heat treating processes. Annealing. This involves heating the material to a specific temperature and then cooling it slowly to make it softer and more ductile. This process relieves internal stresses, improves machinability, and enhances the material's formability. We tend to anneal our steels to soften it to machine parts easier at Silicon Valley Elite Manufacturing. Quenching. After heating the material to a high temperature, it is rapidly cooled by immersing it in a quenching medium such as oil, water, or air. Quenching results in increased hardness and strength, but may also lead to increased brittleness. Tempering follows quenching and involves reheating the material to a lower temperature to reduce hardness and increase toughness and ductility. Tempering helps to relieve internal stresses introduced during quenching while maintaining desirable mechanical properties. Hardening, a process that involves heating the material to a high temperature, followed by rapid quenching to achieve high hardness and strength. Hardening is commonly used to improve wear resistance and surface hardness. Normalizing, similar to annealing, but the material is cooled in still air instead of being cooled slowly. Normalizing refines the grain structure and improves the mechanical properties of the material. Case hardening involves adding a hard outer layer to the material surface while maintaining a softer, more ductile core. Common methods of case hardening include carburizing, nitriding, and induction hardening. Heat treating is widely used in various industries, including automotive, aerospace, tooling, construction, and manufacturing. Proper heat treatment can significantly enhance the performance and durability of metal components, making it an essential process in the manufacturing world. Now we'll go through brazing. Brazing is a joining process used in manufacturing to permanently join two or more metals together. It involves melting a filler metal, known as brazing alloy or braze, and flowing it into the joint between the parts to be joined. Unlike welding, in brazing, the base metals being joined do not melt. Instead, the filler metal bonds with the base metals through a process called capillary action, forming a strong, durable joint. The brazing process typically involves heating the assembly to a temperature above the melting point of the filler metal, but below the melting point of the base metals. This is usually done using a torch, furnace, or induction heating. Once the filler metal melts and flows into the joint, it solidifies upon cooling, forming a metallurgical bond between the parts. Brazing is commonly used in various industries, including automotive, aerospace, electronics, plumbing, and HVAC, heating, ventilation, and air conditioning. It is favored for its ability to join dissimilar metals, high joint strength, and versatility in joining complex shapes and assemblies. Brazed joints are also often more resistant to corrosion compared to other joining methods like soldering. Overall, brazing is a valuable technique in manufacturing for creating strong, reliable joints in metal assemblies. Now we'll uncover why brazing and heat treating are both crucial processes in the manufacturing world for several reasons. Joining and bonding. Brazing provides a means to join different types of materials together, including different materials which may not be possible through other methods like welding. This capability is essential for creating complex assemblies and structures in various industries. Strength and durability. Brazing produces strong, durable joints that can withstand high levels of stress and temperature variations. This is vital for applications where reliability and longevity are critical, such as aerospace, automotive, and industrial equipment. Precision and versatility. Brazing allows for precise control over the joining process, enabling manufacturers to create intricate and precisely engineered components. It is also versatile, capable of joining a wide range of materials and shapes. Enhanced material properties. Heat treating alters the properties of materials such as hardness, strength, toughness, and ductility to meet specific requirements. This is essential for optimizing the performance of components in various applications, from wear resistance in tooling to load-bearing capability in structural parts. Controlled microstructure. Heat treating enables manufacturers to control the microstructure of materials, which directly influences their mechanical properties. By carefully manipulating the heating and cooling processes, manufacturers can achieve desired characteristics like fine-grained structure, uniformity, and homogeneity. Improvement of machinability. Heat treating can improve the machinability of materials, making them easier to work with during subsequent manufacturing processes such as machining, milling, and drilling. Quality assurance. Both brazing and heat treating processes can be tightly controlled and monitored to ensure consistency and repeatability, leading to higher quality finished products and reduced scrap rates. Cost effectiveness. While both processes may add to the manufacturing costs, they often result in cost savings in the long run by improving the performance and lifespan of components, reducing maintenance needs, and minimizing the risk of premature failure or breakdown. Overall, brazing and heat treating are essential manufacturing processes that contribute significantly to the production of high quality, reliable, and efficient products across various industries. Every time I interview a guest in manufacturing on my show, I'm learning something new about this industry and I bring it into work applications. We had our very first brazing project after Glenn's interview. I hope you're taking away golden nuggets that are helping you with your business as well. Next week, I have an awesome guest on the show who will be demystifying that Gen Z are lazy and entitled. Her name is Kyla Zhao, and she's been in the headlines lately. It's going to be an amazing show, so you won't want to miss it. Before we wrap up, remember this. Manufacturing isn't just a career choice, it's a lifestyle, a mindset, and a journey of constant discovery. So my friends, keep making things fun, cool, and undeniably sexy. If you or you know someone who would like to be on the show, please email me or DM me on Instagram or Facebook. If you enjoyed the show, don't forget to subscribe, share, and spread the manufacturing love. Until next time, keep creating, keep innovating, and always keep it fun, cool, and sexy. See you guys next time.